Hello everyone and welcome. I'm Somi Cham and this is part of our statistics series where we explore how data helps us make meaningful research-informed decisions in the field of education. Today's topic is about using descriptive statistics and visualizations to understand variation and make comparisons across groups. Specifically, we will focus on Boxplots, a powerful tool for summarizing data distributions and highlighting key statistical measures such as medians, quartiles, and outliers. Boxplots help us visualize the spread and central tendency of data, making it easier to compare different groups and identify patterns or anomalies. By using boxplots, we can gain insights into the variability and consistency of educational data, which is crucial for making informed decisions and improving educational outcomes. Let's dive in and explore how boxplots can enhance our understanding of data in the field of education. Imagine you're part of a school district that wants to evaluate the nutritional value of its elementary school lunch programs. You partner with a nutritionist and gather data on calories, protein, fat, and fiber from lunches served at 20 schools. At first glance, every lunch seems similar: a main entree, fruits, vegetables, and milk. However, just like students, not all lunches are equal. Some are more nutrition-rich than others, and that variation matters, especially in districts where lunch might be a child's most nutritious meal of the day. This is the first lesson in educational statistics. What looks similar may not be the same when you dig into the data. To compare nutritional content, the team processes each school's average weekly lunch menu, calculating grams of fat, protein, and total calories. In research, we call these operationalized variables. While we might be interested in broad constructs like nutritional value or student wellness, we need measurable indicators like protein content or sodium levels to do the analysis. This same logic applies when studying things like student engagement, literacy development, or school climate. We rely on proxies like time on task, reading accuracy, or survey items about belonging. They are not perfect, but when selected carefully, they give us valuable insights. Let's say you compile the calorie content from the 20 school lunch menus. The values range from 510 to 780 calories per lunch. That's a pretty big range. To understand this distribution, one useful measure is the median, the midpoint of the data when sorted. In our case, the 10th and 11th calorie values fall at 630 and 650, so the median is 640 calories. Why the median? Because it gives us the typical school lunch, and it's less sensitive to outliers than the mean. In education, we often use the median for test scores, survey results, or teacher evaluations, especially when there are unusually high or low values that might skew the average. To understand spread, we calculate quartiles. The first quartile, which is the 25th percentile, represents the middle of the bottom half of the data. Let's say it's 580 calories. The third quartile, which is the 75th percentile, represents the middle of the top half of the data. Maybe it's 700 calories. Our 5-number summary then looks like this. The minimum value is 510 calories. The first quartile is 580 calories. The median is 640 calories. The third quartile is 700 calories. The maximum value is 780 calories. This gives us a sense not just of where the middle is, but how spread out the data is. This is critical when evaluating equity or consistency in educational services. So another context, student reading growth. Suppose we administer a fluency assessment across 20 classrooms using a standardized measure. If we get similar 5-number summaries, we can quickly compare how different classrooms perform, not just in terms of averages, but in terms of spread, which matters when ensuring all students are supported, not just the high achievers. A box plot is a powerful way to represent that 5-number summary visually. We draw a box from quartile 1 to quartile 3, add a line at the median, and stretch whiskers to the minimum and maximum. It gives us a clear, compact visual of the data center and spread. Now imagine comparing lunch calories between Title I schools and non-Title I schools, or comparing urban and rural districts. With box plots, you can instantly see which group has higher medians, wider variability, or potential outliers. The same applies to student performance, comparing math achievement by school, by teacher, or by intervention program. Let's say we run a reading intervention in 10 schools and want to see if it worked. We generate box plots of pre-test and post-test fluency scores. Even before running statistical tests, the visualization shows whether median scores increased and if variability decreased, strong indicators of program effectiveness. In education, data informs everything from policy to classroom practice. Whether you're analyzing school improvement plans, evaluating an after-school program, or studying disparities in student discipline, descriptive statistics like medians, ranges, quartiles, and box plots give us tools to summarize and compare without oversimplifying. These tools help us make sure we don't just focus on averages, but look at the full distribution of experiences. We use visualizations to communicate complex data to stakeholders, parents, or school boards. We remain attentive to both equity and effectiveness. So, remember, statistics aren't just about numbers. They help us tell stories about students, schools, and systems grounded in evidence. Let's see another example. Consider the scenario of evaluating student attendance rates across different schools in a district. Suppose we collect data on the number of days students attended school over a semester from 20 schools. The attendance rates range from 85% to 98%. To understand this distribution, we again use the median. If the 10th and 11th attendance rates are 92% and 93%, the median attendance rate is 92.5%. Next, we calculate quartiles to understand the spread. The first quartile, which is the 25th percentile, might be 88%. The third quartile, which is the 75th percentile, might be 96%. So, our 5-number summary for attendance rates looks like this. The minimum attendance rate is 85%. The first quartile is 88%. The median is 92.5%. The third quartile is 96%. The maximum attendance rate is 98%. Using a box plot, we can visually compare attendance rates across schools. This visualization helps identify schools with lower attendance rates that may need additional support or intervention. It also highlights schools with high attendance rates, which could serve as models for best practices. By analyzing attendance data, we can make informed decisions to improve student engagement and reduce absenteeism, ultimately enhancing educational outcomes. Thank you for joining me today. Keep asking good questions and let your data guide you.